Okay, this is a little tutorial on the calorimetry lab, experiment 2 for Chem 3A. So the idea here is that we've got a cup that is going to be our calorimeter, and this is just a plain old styrofoam cup, actually, not very fancy. So we have the cup, and in the cup we have some water that's at room temperature. Okay. When this starts, the temperature of the water, which would be an initial temperature, is equal to the temperature of the cup because they're both sitting there at room temperature. So we have the cup and the cold water being at the same temperature. Let's color in that cold water. So here's the cold water. The cold water has a mass. So we have a mass of the cold water, and then what happens is we add some warm water. We're going to add some warm water, and the warm water has a particular initial temperature also, Ti. What happens then is that the heat is transferred from the warm water to the cool water. And ideally, the cup would be left out of it, the calorimeter, but in fact the calorimeter also absorbs some of the heat from the water. So we have heat lost by the hot water, we'll call that Q hot, and we have heat gained by the cold water, and we have heat gained by the calorimeter. We'll call that Q cal. These have to add up to 0 because the energy of the universe is constant. The heat lost by the hot water is gained by the cold water and the calorimeter. So for each of these Q's, we have the equation Q equals mc delta T. I forgot to mention that the warm water also has a mass that's usually going to be given. So we have a mass here given of the warm water. So each of these Q's is mc delta T. Q hot equals the mass of the hot water times the specific heat of the hot water times the change in temperature of the hot water. I'm using colors here to code for the different things. For the cold water, the same is true. Q for the cold water equals the mass of the cold water times the specific heat of the cold water times the change in temperature of the cold water. Well, we talked about the initial temperature. The initial temperature of the warm water is higher, and the cold water and the cup, the calorimeter, are at the same temperature. What is the final temperature? Well, the final temperature is going to be the same for all of them because they're going to go to the same temperature. So T final for the cold water equals T final for the hot water equals T final for the calorimeter. So the final temperature for all of these is going to be the same. In the prelab for this experiment, what they want you to find is the amount of heat absorbed by the calorimeter. So what you need to do is you need to calculate Q hot using this equation. You need to calculate Q cold using this equation. And then you can solve that for Q cal, the heat absorbed by the cup, because we know that the three of these things added together have to equal 0. So you're going to need the mass of the cold water, the mass of the hot water, the initial temperature of the hot water, and the initial temperature of the cold water, and the final temperature, which is the temperature of all three. So give it a try and let me know if you have any questions.